Good morning to most of you and good evening to some of you that are in attendance today. This is now week 14, and we are talking about protecting instrumentation through diaphragm seals. Today, we have Mark Leonelli from REOTEMP with us. And as far as our audience goes, we have a lot OEMs, chemical plants, manufacturing, engineering, and some universities. And the geography is quite extensive today. In fact, we have some folks from Alberta, Canada, in Belgium, if you were wondering what that country was, and from India joining us today, and naturally all over the US. So thank you for joining us. As far as Peerless goes, many of you have heard this before, some of you haven't. We become a trusted source for process components to help keep plants operating efficiently and projects running smoothly, on time and under budget. And we're proud to help our customers navigate the toughest industry challenges. We have three segments of our business. Our ProCore segment really works with our OEM customers and our custom engineered equipment builders, and our process group. We work with chemical plants, the pharmaceutical, and others in the manufacturing sector. And our High-temp fabrication division, which we manufacture high-temp insulation, refractory, and scientific surfaces. In fact, tomorrow we're hosting another webinar with Trespa, who makes our phenolic surfaces. That one will be at same time tomorrow. So Mark Leonelli is a national sales manager for REOTEMP. He has been there many years, wearing numerous hats. He's from San Diego, California, which is where REOTEMP is headquartered. Dan Morgan is with us. He'll be our moderator today. Greg Barrow runs our process group, and I work primarily with our ProCore group, or our OEM customers. So Mark, among many things, he is a baseball fan, and I put it in quotes because what he is may cross the boundaries of regular fandom. If you're wondering what all those red X's are, that is all the baseball stadiums that he's been at. If you're doing the math, he's been at every one except the new Texas Rangers Stadium there in Dallas-Fort Worth area, I believe. So these days it's been trying for him to get to stadiums so he can be seen peering out windows of hotels overlooking stadiums, which is something to do anyway. So Mark, congratulations on your fandom. That's a little bit nuts. So with that, I am going to turn it over briefly to Dan Morgan, who will again talk about how the meeting will flow today. So thanks again for joining us. And Dan, take it away.
All right, thanks, Kevin. And yeah, thanks to everyone for being with us today. Some of you are with us for a second, third, or more time, so feel free to tune me out for the next few seconds. But I just want to kind of run through a few things of how this is going to work and kind of what you're seeing in the interface here. In just a few minutes or a few seconds, I'll turn this presentation over to Mark, and he's going to get started on his presentation. But you will see in the control panel of the interface here a section for questions. So as Mark is going through his presentation, if there's anything at all that you're unclear on or unsure of, or maybe an application-specific question that you'd like to discuss with Mark or with us, please don't hesitate to type out and ask us a question through that panel. And that's what I'll be doing is keeping an eye on those questions that come in, and I'll find moments to interject during Mark's presentation and make sure we get those answers for you. It's also possible that we'll maybe spend some time asking or answering some questions at the end of the webinar. So yeah, don't hesitate whatsoever to send anything in. There's also a chat panel, so if you're having anything, any issues maybe with the interface or what you're seeing or hearing, feel free to send me a chat or ask a question through there, and I'll be happy to help you out. So yeah, great. Mark, maybe you can come to Buffalo and watch the Blue Jays play sometime, since there's definitely a parking ramp you can stand on top of here. So with that, I will turn it over to you. So here you go.
All right, well, thank you guys very much for the warm welcome, and I'm looking forward to spending this time with you. If I'm not talking about baseball, I really do enjoy talking about diaphragm seals, so why don't we do that? REOTEMP is a U.S. manufacturer based in San Diego, also with a production facility that we opened 4 years ago in the Houston area as well. For those who know about REOTEMP and our 50 years in the industry, it started with bimetal thermometers, but we also have a full line of pressure gauges that we've been selling now for over 40 years. Along with that, we have a Diaphragm Seal line, which we'll be talking about more today, which we have been doing actually almost as long as the bimetal thermometers. We were doing diaphragm seals actually prior to doing pressure gauges. In addition to that, we have diaphragm seals. Our abilities in diaphragm seals, and we'll talk about this, has to do not just with pressure gauges, but also with transmitters, which requires quite a bit of expertise. We also have a full line of thermocouples and RTDs, and we also have a full line of thermal welds to mate with those. We also sell other products that we would consider outside of the core: pressure transmitters, switches, custom RTDs, multi-points. We do customization of dials. We do valves and manifolds, and all different forms of these interface products. Basically, this is the core of what it is we do. In the world of diaphragm seals, there's many different types. One of the things that you can count on with REOTEMP is that all of our materials made in the USA, and all of the products are made in the USA. They're designed for transmitters used on gauges. Everything that we do in regards to diaphragm seals was meant to be at the performance level that would be needed for smart transmitters. But many people use them on gauges. Quickest lead times in the industry. This is what makes REOTEMP who we are. We've been known for the people who do things in days where other people do in weeks. That is something that we continue with all of the lines that we offer. And we're the only U.S. manufacturer under one roof to offer both gauge seals and transmitter assembly. We have the broadest selection of exotic materials and fill fluids, and we'll talk about that in just a bit. And here's some of the other things that we do along the line. We do a lot of customization and a lot of different broad view of different types of diaphragm seals. Let's get into what is a diaphragm seal, why do you use it? The primary reason is to protect the pressure instrument from the process. Things such as heat, things such as corrosion, things such as clogging, these are all things that will stop the pressure instrument from performing, and so you need to protect that instrument. At the same time, in many cases, you're protecting the process fluid from the instrument, and if there's a non-clean out dead leg, which basically means you're building up a residue of product that would contaminate the process, or the instrument itself can contaminate the fluid of the process. This is a reason that you would want to protect the fluid from the instrument. Done correctly, you should be able to do this performance and do this protection without compromising instrument performance and reliability. Now we're going to talk about what does that mean done correctly. A diaphragm seal, primarily, the heart of it is the diaphragm. You'll notice it's about 0.003 inches thick. It's a very, very thin piece of metal that separates and does all the work that's necessary. The lower housing is a much larger piece that's typically about as thick as the process piping, but it's a wetted material, and so it's in connection with the process. Different process connections: threaded, flanged, clamped, welded. They come in many different shapes and sizes. The upper housing, typically not a wetted part. However, there are some considerations that need to be taken place, and we'll talk about those in a bit. The instrument connection, gauge, transmitter, switches, direct mount, remote capillary. There's every different way of connecting the instrument to the diaphragm, and those can be chosen at the time that you're specifying. Okay, as I said, the fluids, I got the fluid up there, you've got the process coming through, and you've got this tiny, thin diaphragm separating the two of them. The way it works is process comes up, it applies pressure, the diaphragm then passes that pressure into the fluid that's in the instrument and pushes it into the instrument. So allows it to basically translate any of the process pressure that's coming up while still protecting it. The idea and how you do this is you have to completely evacuate the instrument chamber. Then you take degassed fluid, fill it into the system, and you basically have created a hydraulic system. Now, once that system is broken, it makes the whole system inoperable. So if there's anything that happens in regards to the diaphragm itself or anything along that line or any of the connections that are there, it'll break the hydraulic system and nothing will work. Okay, diaphragm material. This is key. Metallic diaphragms welded to the seal, leak test, highly impervious. The reason being is you need to choose the right diaphragm material because it has to be compatible with process fluid that you're using. Here's some examples: 316, Astaloy, Manel. We have many different types, and these are all used because depending on what the process is, you may have to use a exotic metal to make sure that you're effectively containing the process fluid. Teflon and Viton diaphragms, we use them in different styles. In comparison to metals, there's going to be some problems with that. Sometimes they're going to be susceptible to leaking. They can be porous. They can be prone to sagging over time. So when you have the choice of using a alloy versus some sort of polymer, it's probably better to go with the alloy. This slide gives you just a snapshot of all the different fill fluids that we use. For high-temp silicone standard, food grade, inert. There's many different types. They have different temperature ranges. They have different viscosities. And so when you're choosing it, you need to be careful to make sure that you're choosing the right fill fluid for your device. Now, there are other styles that we make. I'm going to go through a couple of those styles, and then we're going to talk primarily about our all-welded seal. But the offline diaphragm seal is probably the one that most people are familiar with. It's been in this industry the longest. And it's basically a 4-bolt or multiple bolt unit. It bolts all of the upper and the housing and the diaphragm together. There's a maximum flexibility of material type. When it comes to this style, you can use any different type of, whether you needed to use a polymer, whether you need to use a different type of metal. It allows for the largest breadth of material type. It has the largest breadth of diaphragm sizes, from 2.2 inches to 4.1 inches for highly sensitive applications. Multiple flush and clean out options are available with this that may not be available in some of the other styles. And so those are the primary ones for the offline threaded. Flush phase seals. Yes.
Sorry to interrupt real quick, but we had a question come in regarding diaphragm materials. So I wanted to maybe ask this question before you got too far past that slide. So
sure.
Question came in, do you provide, or is it something that we can provide as a gold-plated diaphragm material, obviously for the process side, and maybe talk about if that's something that is possible. Talk about maybe if you see specific benefits of that, really in regards to like a hydrogen service, and if there's any concerns with I guess holidays in the gold coating.
The absolutely gold plating is necessary. You can obviously come up with the reasons, even though it is only 0.003 mil, why we don't do solid gold diaphragms, but we do gold plating. It is the best way to block the hydrogen leakage, because the hydrogen molecule is so small. And so gold plating is definitely something that is appropriate in certain applications. The industry typically does it as a 1 mil thickness. Ours is double that. But it's something that we do, something that the industry is common in the industry, and in certain cases, there's no other way to do it. It's not the most inexpensive way to go about it, but it's a sure way of handling hydrogen process.
Okay, perfect. Thanks, Mark. Yeah, I'll let you know if there's any follow-up questions that come.
Yeah, if there's any follow-up on that, let me know, but it's definitely something that's available. Now, that would be something that gives a good one where we were talking about the offline diaphragm seal. That would be available with the offline diaphragm seal, where it wouldn't be available with, let's say, the all welded or something along that line. So you're on the screen, you're actually looking at the diaphragm seal that we would use for gold plating, but we also do it with our flush faces as well, which I'll talk about right now. The flush face seal is one where if you have highly viscous fluids or media with high solid content, you don't want the stuff building up. And so you want it moving through. You don't want to have any areas where process fluid could build up in little cavities or things that might be available and offline. And even though there is flushing options for the offline seal, there's still certain applications where you just don't want the risk of anything building up, and that's where the flush face seal comes in handy. In addition to that, where there's certain times where, because of the tank, let's say, or something along that line, where you want to use a flush face, but you still got the cavity that brings it all the way to where the process is at, we will do extended diaphragms with flange nozzles, and that will fill up the dead leg. You can see that in the picture over here, where different types of nozzles can be used to extend the diaphragm. The only limiting factor for a flush face seal is whatever your process connection, that's about as big as you're going to be able to get for the diaphragm. So in small flush faces, you're only going to be able to have small diaphragms, and so that will limit the type of, if you have a low pressure application, it simply wouldn't work. And we'll talk about why that's the case. The third type is the all welded process seal, which this is probably the one that I'll be talking about the most in regards to the different architecture of a seal. Some of the advantages for the all welded is no internal gaskets, no polymer, no elastomers. It's basically a all metal architecture, and that makes it perfect for high temp services. You don't have to limit the ability of the diaphragm seal assembly, because you've got a elastomer that's rated up to 500 degrees Fahrenheit. So you have the heat resistance that comes with metal, and this is why we oftentimes will use this style to introduce our cooling tower. And what our cooling tower is that allows the assembly to cool down the process even more so. So if you have a really high temperature process, you can bring it into the diaphragm seal. The cooling tower will then cool it even further. So by the time it gets to the instrument, it'll be to something that it's manageable for the instrument. In many cases, smart transmitters are limited to about 150 degrees C, in some cases even less than that. And this configuration will allow the process to be cooled so that by the time the heat gets to the instrument, it's manageable. Another aspect of it is all completely welded, so it's completely sealed. So any application that may have fugitive emissions, there's no threaded, there's no leak points, there's no bolts, there's nothing. It's a great application. It's a great style to use when fugitive emissions are concerned. Some of the markets that we use, it's obviously oil, gas, and is primary wherever there's sour gas applications. Power gen, where high vibration and pulsation, because of the all-welded nature of the MS8, it's going to be able to hold on and perform well in high vibration situations. And then for chemical processing and manufacturing, we've designed certain models that are excellent against corrosion and abrasiveness. As mentioned before, the all-welded design takes care of and prohibits fugitive emissions. Gasketless feature allows for a minimum amount of leak paths. Tamper resistant. What this means basically is back when you saw the offline seal and we had the 4-bolt seal, those were made so that they can be maintenance. You take the bolts out, you clean them up, and you basically maintenance it the way you would, let's say, your car, keeping it running as long as you possibly could. The problem, of course, is that practice went by the wayside, and people weren't being taught how to properly use them. And so what happened is, because as you go back to that 0.003 diaphragm, in many cases in handling the diaphragm seal, they would puncture the diaphragm and make it and ruin its operation. This is one of the reasons that the all-welded seal ends up being tamper-proof. So we've kind of gone 180 degrees away from the original, and this allows the device to be handled without it being mishandled. And then in regards to certifications, we're kept up to date with all of our NACE certifications in regards to our MS8. The MS8, I showed you the ones that had threaded connections, but flange process connections are available in the all-welded. There's various materials that we use, Monel, Hastelloy, along with the 316. The integration of a Monel gauge, I'll get to that. That's a redundancy feature, and that's very specific for one application. And then the 316 standard is upper is a standard, but we do have the capability of doing exotic uppers. That's very rare, but in certain cases, the ambient conditions that the part in calls for it. This is the application that probably defines the most sophisticated and demanding requirements for this, and so this is what I'm going to be talking about, and that's hydrochloric acid. In situations like these, you have to be doubly sure that you're creating an instrument and an instrument assembly that is going to keep the user safe and the facility safe by not allowing any emissions or fugitive emissions to escape. The HF gauge, safety gauge, which I'll talk about in just a second, can also be used. It's not just for HF. For any times we have sulfuric acid or chlorine or things along that line, this is a great solution for those as well. And then we'll talk about dual containment in just a second. These are the questions and these are the aspects of a gauge that's in these hypercritical applications that you should be asking, are these things available? One is, does the gauge specify that this is for the service that it's being used in? If it's an HF service, there needs to be some sort of alert so that the operator knows that this is what is being is processed and what the gauge is for. The all-welded, no leak points. That's another aspect that you should always be asking. You shouldn't be using an assembly that has any sort of leak points in it. Acid detecting paint. If any up to 3 pH comes into the general area of the ambient, that's an indicator that there may be a leak, and that yellow painting, it'll turn bright red. It's almost like it's bleeding. That's an indicator and a safety mechanism that can be used. all Monel welded parts. This is the double redundancy that I was telling you about, where the EPA regulations call it out. In this particular case, you would use a Monel gauge with Monel internals along with the Monel, or in this case, in many cases, Hastelloy seal. So it becomes, if for whatever reason the diaphragm is breached, you still have welded parts that can handle the process while the system is shut down. And then isolated diaphragm welded inside seal of body. This is something we do that's a little different, but let me explain it. If you look at the seal body down here, what you're seeing is the area where the weld is and the diaphragm's at. In most cases, the lower, the diaphragm, and the upper are put together and then they're welded across the diaphragm. Ours is actually a little different. We take the diaphragm and we do an independent weld to the upper so that it is not, so you have one weld that's inside of the seal body there where the diaphragm is welded to the upper. Then we take that piece, take it to the lower, and then we do the external weld as well. So you actually have two welds in this particular case. Diaphragm size. Identifying the diaphragm size that you're using for your application is critical. If you choose the wrong diaphragm size, your assembly is not going to perform the way that you want it to perform. Diaphragm must displace enough fluid to drive the instrument. In other words, if you have that force that we talked about earlier that's coming up and then the diaphragm is pushing that into the instrument, if there's not enough strength for the diaphragm to do that, if let's say the board on tube is so large that the amount of pressure that the diaphragm is pushing is not enough to actuate the board on tube, you're not going to get a proper reading or no reading at all. Same time, the diaphragm must be sensitive enough to measure the applied pressure. So if you have a very small diaphragm, it's not going to sense a small amount of pressure. For small pressure, large diaphragm. That's the rule. Give you a little bit of an example here. Over here, you've got a picture here that explains you've got 0 psi, so there's no applied pressure going on here. You've got 3 different instruments with 3 different diaphragms, and you're in an oven that's 125 degrees. If you look at the 2.2-inch diaphragm, it's reading perfectly. It's right on 0. If you look at the 1.5, it's actually reading pressure. And if you look at the 0.7, it's reading a lot of pressure. Why is that happening? Well, that's because there's a certain amount of expansion that's caused by the heating up of the fluid. And that expansion, if it's not being absorbed by the diaphragm, it's going to interpret itself as pressure. This is why you always want to make sure that you're giving the right diaphragm size for the pressure that's required, or else you're going to get a false reading like this. Okay, now I'm going to switch over to our online configurator, and we're going to build a part together that kind of goes through all the different things that you were asking about. REOTEMP has a full line of online configurators that basically allow you to build any product that we make, specify the different options of it, and create a part drawing and description for yourself. So let's go ahead and get that done. Okay, when going into the configurator, you can see all the configurators that we have available. I have chosen the Diaphragm Seal configurator. By the way, in case you don't want to do this and you have an application, you can click this button. It will submit a form to you. You can fill it out, send it to us, and we'll do the work for you. If you want to configure your own, follow me. Okay, so now what you're going to do is you're going to see all the different instruments that REOTEMP provides, pressure gauges, transmitters, switches. In this particular case, I'm going to choose a process connection or process gauge, and we'll go from there. Now the system is going to say, okay, you've chosen the process gauge. Is it going to be a bottom connect or a back connect? I'm going going to choose a bottom connect. Now, once you've chosen all the things that are necessary for this page, this little thing will become green, and it'll allow you to move forward. Then it's going to ask you, okay, your pressure units, how are you measuring it? Are you doing dual scales? Are you doing bar? How's that working? I'm going to choose PSI. And then I'm going to choose, just for the sake of talking about diaphragm sizes again, I'm going to choose a 0 to 15 PSI gauge. Then we chooses the case fill. This is not the assembly fill. This is the fill that you would put inside the case in case you want to combat vibration. Glycerin, glycerin water, silicone. Here's a side note. If you have a low temperature, the temptation is to go with silicon, and that's perfectly fine. However, I would suggest the glycerin and water mix. The reason being is it's a thicker, it ends up being a thicker substance, and it's less prone to case leak. It's also gentler on the gaskets inside the gauge. So, and it performs just as well as the silicon does. So when in doubt, choose glycerin water, which I'm going to do. We have different types of windows: tempered glass, laminated safety glass. I'm going to keep it with the tempered glass. Different options that we have: high-vis dial, min-max pointers, electrical contacts, 3-point traceability, 3-point cal, positive material PMI. Those are just different options that you can choose. Now it's going to ask you about your what is your configuration? What's, do you have capillary? It's being connected to the gauge. Is it a threaded gauge? Are you going to be welding it? Do you have a cooling tower? What's your configuration? I'm going to choose the direct thread. And as you saw, it turned green, so now I can move forward. And I'm going to choose, you can do flange, sanitary, saddle. These are all different threaded possibilities that are here. I'm going to choose the NPT thread. And that's going to, once I did that, it's going to limit the possibilities that I have. I can either choose a flow ring or I can choose a threaded offline seal. And that's what I'm going to do. So now it's going to let me go forward to talk about the seal properties. The first thing it's going to ask me is, what's your diaphragm material? Hopefully I've done my research by looking through my alloy compatibility charts, and there's lots of different things that you can use. Fortunately for me, my process allows me to use a 3/16 stainless, which is the most common. And now I'm going to choose my diaphragm size. You're going to notice the configurator is not going to let me choose a size 5. Why is that? Because my pressure is too low. If I choose a size 5, it's not going to be able to drive or give an accurate reading for the 0 to 15 PSI. So it's going to tell me I can use a size 6 or a size 7. In this particular case, we're not talking about inches of water or something that's really low. So the size 6 is perfectly fine, and that will probably save me some money if I do the size 6 rather than the size 7. Seal body welded. I want it to be consistent with the welded material that I have available in the diaphragm. In certain cases, there's going to be a difference between the wetted surface of the lower and the wetted diaphragm. Either one, because the diaphragm is of a very expensive metal, and since you have a much thicker lower, you're allowed to use something that has acceptable ratings rather than the optimum ratings. That's why oftentimes you're going to find a stainless steel lower with a tantalum or titanium diaphragm. So I'm going to go with my 3/16 lower. And it's going to talk about process connection threads. The most common in the industry is a 1/2 inch NPT female. But there are others that are available, 1 inch, 3/4, 1/4 inch. I'm going to go with the 1/2 inch NPT female. We also have custom ones that are available. These ones wouldn't be something that we would have necessarily the piece parts on the shelf, but it's definitely something that we can machine and have ready for you relatively quickly. Now I'm going to choose the upper body seal. And now in this particular case, in many cases, people are just trying to go with the least expensive. For us, that's typically something like a 304 stainless or maybe a carbon steel. Because of the amount of diaphragms we do and amount of seal assemblies we do, our 316 is just as inexpensive as, let's say, the 304. But in certain cases, because of the ambient environment, people may have to take an exotic metal because there is aspects in the ambient environment that would eat away at 316. And so we do have those options available. HF Service is a good example of that. Flushing connection. What's that? That basically allows you to flush the areas that where possibly process can build up. And so what you're going to be able to do is connect a hose or some form of thing to the opening, take the top off, plug it in, flush, get all the stuff out of your system, and then go back to operating. In many cases, the single 1/4 inch NPT is the most common, and I'm going to choose that. Then there's the bolting system. In many cases, the bolting system depends on what kind of pressure rating you need. In this case, since we don't have a high pressure, I'm going to go with the stainless steel bolts for material compatibility. There's different types of gaskets that are available. We standardize on the Klinger for standard temp applications, but if you have a high temp application, the Grafoil one is available as well. And then there's different types of polymer gaskets that are available if the process requires that. I'm going to choose the Klinger. Okay, so now I've got this to the point of the fill fluid, and I'm going to say, shoot, what's the fill fluid that I need? If I needed something that was, let's say, 375 Fahrenheit or above, I would go to the high temp silicons. If I had perhaps a oxygen service where I needed an inert fluid, we have those available as well. If I was in a sanitary environment where I needed food grade, we have those available as well. The standard by far is silicon DC 200, which is what I'm going to choose in this case. Okay, now I'm going to go to the different options that are available. And the first option that's available is Pulse Plus. I'm going to digress from the configurator for a second because I want to show you a video that describes the Pulse Plus option that we have. It's in many cases when there's pulsation. Pulsation is the ultimate gauge killer. Many people confuse pulsation with vibration. Pulsation is when the system is sending you basically a hammer coming through your process, and it is attacking the gauge with force. And in this, well, vibration is an external, it's coming from an externally. In this particular case, most people use snubbers, and snubbers are very good. We offer them, of course. Snubbers are a very good way to offset pulsation. However, if you have a diaphragm seal assembly, we actually have kind of a nifty opportunity to use our Pulse Plus system that's only available in diaphragm seal applications, and I'm going to show you how that works. Basically, you've got two gauges set up to on a T, so they're both going to see the exact same pressure. The one on the left is just using a standard snubber, so it is set to withstand pulsation, and the one on the right is using the Pulse Plus system. Now, the process is going to come in, and it's hitting them both at the same time. Now, look, the one on the left is actually working relatively well, because if you didn't have a snubber on there, that thing would be flying everywhere. However, that's what a Pulse Plus does. And basically, it's because it takes the vibration, dissipates it into the diaphragm seal fluid, and this really will allow your gauges to last an incredible amount of time. So, sorry for the diversion there, but now you know that you have that option available, and I, of course, am going to choose it. Other options that we have: oxygen service, things being cleaned for chlorine, plugs for flush ports, tag options. Almost everybody who's doing a project is going to be using tags. We have large tags, we have small tags. When you choose the tag option, it will let you put in what your tag number is. So let's do PI 1234 as my tag number, and we'll see where that comes in later. And then other different things are available: NACE certification, general material reports, mill port, PMIs, hydrostatic testing certificates, all the things that come typically that we are doing, but if you want certification for them, we can provide that. Then your final part is, now you have created this basic quote. It's giving you your standard pricing without discount, and it gives you all the description there. And while you were choosing these options, you are also creating a PDF drawing, and that drawing can be seen like that. So now you have all the documentation on a drawing. You'll notice that it did take into consideration the tag number that you identified when you were identifying your tags, and you now have, and that's something that you have as well. And then you can add your assembly to the quote and send that quote to yourself if you've signed yourself up on the configurator. Okay, now I'm going to swing back to my presentation and just give you one other thing to think about when it comes to REOTEMP and our capabilities. The keys to ideal performance, one more time. Helium leak check diaphragm welds, that's one of the certificates that we make available for you if you'd like, but it's something that we do with all of them. 24-hour minimum fluid degassing. This is why when someone wants something same day, we're going to tell you no, because we want to make sure that we're doing a complete vacuum evacuation, which we have a very high ability to do that in our instrument chamber. High-temp thread sealants and inspector seals are put on all threaded joints so that you can see that if any sort of manipulation has taken place, it'll become evident on the just by visual look. And then we do a verification of instrument calibration and build system leak check at the end of all of our assemblies. A last point, and this is something just that I've observed in my years in the industry, and that is that when, let's do first, sorry, I'm one slide ahead of myself. Other things that can take into consideration that should be part of every one of your diaphragm seal assemblies is that they should be static, vacuum, and pressure tested. That verifies the integrity. All welded and standoff connections, no threading. Configuration of the transmitter, we do complete calibration. Low volume modification to factory process covers. Basically what happens is when someone sends back a transmitter where they want an assembly put on it, we'll actually replace the factory cheeks that have a lot of room for fluid, and we'll put in cheeks that have a very small amount of liquid in them so that they have a higher accuracy. In the diaphragm seal service, what I was going to mention, what I see a lot out in the field is people have a tendency that when the diaphragm seal assembly breaks, they throw it away and buy a new one. Well, that's one way to do it, but almost every time the instrument is still good. And so this is an opportunity. What REOTEMP does is we'll take back your broken seal assembly and we'll fix it. Why would you want to go that way? Well, one, you don't want to keep throwing stuff away. It's bad for the environment. But one, we're fast. Two, it's less expensive. And we do have the ability to do this very quickly in a 24-hour turnaround time frame in case you have an emergency. So it's just something to think about prior to throwing your instrument assembly into the waste bin. Think about REOTEMP, see if you want to repair it. If it's something that's worth your while, we'll help you out. And that's where you would contact your local representative, like Peerless. And that is that.
All right, awesome. Thank you, Mark. So I am going to quickly turn this back over to Kevin, but as I do that, there was a follow-up to our earlier question about the gold plating. So the follow-up question to that was, is there anything that you provide in terms of like a certification or any kind of report that guarantees, I guess, the like surface finish and any like voids or holes that might be in the coating?
Voids or holes would be done really through the testing that we do. So that wouldn't be something that we would have a verification that would be, let's say, topical or pictorial, but that would come through the testing. But certainly we would send certifications for the thickness.
Okay, all right. Okay, yeah, we'll check back in with the individual who asked that question and see if there's maybe anything else that we can provide or any other follow-ups to that. But
yeah,
it's actually all the.
Be happy to answer.
Yeah, sorry, go ahead.
No, I was just going to say, be happy to answer any specific questions that are, application related, if they need more information.
Yep, absolutely. All right. There's actually no other questions in the queue right now, so I guess Kevin's got a couple of things he wants to mention here, but if anyone else has anything on their mind, we'll be around for another few seconds, so please don't hesitate to get your questions in now.
Thanks, Dan. Thanks, Mark. Really appreciate you being here with us today. One thing I would like to point out, the configurator program is a really great tool, and those prices that you would have seen would have indicated list pricing. We just ask that if you join up and sign up through the configurator program, that you just fill in a note where it says Peerless is your distributor, and we'll make sure that you get the discount off of list pricing that you would deserve. So again, thanks for attending. We are here for any challenging applications you may have in the future. As far as next week goes, we are still working with some manufacturers. We actually have about 6 or 7 topics that we are working on fine-tuning. So we will be announcing what we will be doing next week very shortly. So again, we will have a Trespa phenolic surfaces program tomorrow. If that's of any interest, just let us know and when you get the survey. So thanks again. Have a great week, and thanks for attending, and stay safe. Bye now.